Hey there. So now it's time that we begin talking about few concepts that I have listed over here. We'll talk about each one of them one by one. And if you're a beginner, don't know about what these concepts are, don't worry, stick till the very end because we are going to cover everything that we need from a beginner friendly standpoint. Okay, so let us pick. So we are going to talk about Docker, AWS ECS, AWS ECR, and AWS Fargate. Now, first let's talk about Docker. So what is Docker? So before I talk about Docker, let me give you a overview of what used to happen before Docker was there. Now, I'm just giving you this overview and explaining Docker for those who don't know what Docker is, because everyone who is watching this might not know what Docker is. So before Docker, what used to happen is if you are working in a team and if you share your development files with someone else or in the team to run that same project on his machine, okay, you used to hear this term very often. So that other person will say, hey, it's the project you shared is not working on my machine, okay, and you will reply that, hey, it works on my machine. So this was a very common thing that you used to hear before Docker. Even you might be hearing this today, okay, but Docker solves this problem and you can use Docker as a solution there. I'll explain how. Okay, so you're working in a team, you have a project that you're working on and it's working on your system, and your friend asks or your teammate asked you to share this project with him. So either via Git or either via Drive or something like that, you share that project with him. He runs it on his system and it is not running on his system. And your reply, he's going to tell you, hey, it's not working on my system. And you're going to tell him that, hey, but it's working on my machine, So what used to be problem over here? So problem over here used to be that apps depend on specific OS settings, libraries, software versions. There are tons of things, the environment in which app is running in, right? So when you're working on a project, you might have installed some dependencies of a certain versions. You might have certain settings in the operating system that you have. Certain libraries might be present, might not be present. There, you must be running it, and it is working on your system. But when you share it with someone else, that same environment might not be there with him. He might have a different software version, or he might not have a software version at all. So if I have to give you an example of a Java-based application or a Python-based application, let's say you're running a Java-based application onto your system. So on your system, let's say it is running using a Java version 24, which is the latest. Okay, you're using Java 24. Okay, but if you give this to your friend, okay, and your friend might not have Java version 24 and he might have Java version 21 installed. Okay, so this is a mismatch, and what would happen is the app is expecting Java version 24 to be there, okay, but he is having Java version 21 and he has no idea. He's running and he's getting an error. It's not running on his system, right? So this is just one example that I've given. There would be tons of other things, like a few libraries are not installed. There are specific OS related settings that might not be there. Okay, so this was a problem. Sharing your projects and everything with someone else was a problem because you also had to share the list of things. So, hey, you install Java version 24. I'll have to tell my friend, you install Java version 24, you install this, you install that and everything, right? But with Docker, what happened is you could package all of the dependencies along with the application into a thing and into a box, you can say, and you can share it with anyone and it would run the same way it's running on your system on someone else's system. Okay, so that is that was a problem Docker solved. So what is Docker? Docker is nothing but a tool that lets you package your app and everything it needs into a portable container. Okay, I repeat, it's a tool that lets you package your application along with everything it needs into a portable container, and you can share that portable container with your friends or whoever you wish to, and it is going to run the same way on others' machine the way it's running on your system. Okay, so this is what Docker is. So I've added the definition over here, which I said just now. Okay, so this is what Docker is. Now, Docker has a few concepts, and one concept is the concept of image, and then you have something called as a container. Okay, so let me explain in simple terms what image is. So see, you want to share your application with someone along with its dependencies, like everything that it needs, the right side of environment. Okay, so what you're going to do is you're going to create a blueprint. Okay, and that blueprint is going to be image. Okay, it is going to be called as image. And what is this image going to have? It is going to define everything, like how your app runs, okay, what all your app has, what all runtime environment it needs, the libraries, the dependencies, the configuration. It is going to have everything. So this is nothing but a blueprint that is going to define the right set of environment for your application along with your application. So image is going to define your application along with everything it needs, right? And then this image, you can run this image. To run the application, you will have to run this image, okay? And that is what is known as a container. So image is nothing but like a recipe or a blueprint you can think of for a container. And then when you run this, you have container and your app is running within this container. So it's like a smaller version of you can say operating system, very small version, very light version. You cannot pack operating system like this and give it to someone, right? So it's very lighter version of what your application just needs to execute, right? Like if your application needs Java 21, so you're going to mention that in the image. If your application needs Python as well, you're going to mention that. Any sort of settings, you can mention that. Any sort of jar files, you're going to mention that, and you're going to create an image out of it. Once the image is created, you need to run the application, right? So you will be running the image, and when you run the image, the app runs inside a container, and that is called a container, right? I hope this is making sense. Now what happens is, images can reside on your local machine, okay, but there are a lot of public images that are available. So usually what happens is, if you have Docker, you can run PostgreSQL, you can run MySQL, you can run a lot of things, right? And there are publicly available images for the same that have been created by the respective vendors, right? So you don't need to install a PostgreSQL if you have Docker installed onto your system. You can just pull an image. You can take an image and you can run the image of PostgreSQL, and PostgreSQL will be running on your system. So what happens is, see, you can host your images. The point I'm coming to is you can host your images. And where would you host your images? So you can host your images to share it with the world, right? And you can host your images on a registry. Registry. So registry is a place. It's like a storage place for your Docker images. So if you are creating some images, let's say you're working on an open source project and you converted that into a Docker image and you want to share it with the world, so you will host it on a registry. Now it's not like all the images that are hosted on the registry are public. Okay, you can even have private images defined, right? So you can have, so in simple terms, understand or to define registry, it's a storage place for your Docker images. Images can be public as well as private. If you make it public on the registry, it is going to be available or visible to the entire world. If it's private, it will only be visible to you. Okay, so that is what registry is. Now this is the official website of Docker, as you can see. Okay, it's docker.com, and you would see over here it's prompting me to download Docker. Okay, and yeah, here if you come, this is the Docker desktop. If you download Docker desktop, this is what the UI you see, and you can see containers, images, all these terms that I've explained, right? You can see all this over here. So you can create images, and then if you run the images, they run as containers. You can see view all your running containers or an application over here, right? And you can see over here, what is Docker? Accelerate how you build applications, share and run applications. Okay. So this is the Docker website. You can explore this. It's very popular these days and a lot of organizations use it. Okay. Almost like every organization I see in my network is using Docker. Okay. So that's how popular it is. And there are lots of demand for this kind of technology. Okay. Then you have Docker Hub. Now Docker Hub is nothing but a Docker registry. It's a registry where you can host the images. Okay. So you can see over here, easiest way. Okay. If you scroll down over here, you can see all the images. So you can see Docker official image. If you click on this, you can see these are all official images like Nginx, Redis, Postgres, Ubuntu, Python, MySQL. These are all official images on Docker registry. So if you want to make use of RabbitMQ, for example, there is an official image for this. So you need to install Docker desktop onto your system. Okay, I'll install Docker desktop onto my system and I'll just get this image onto my system. Okay, so I'll just open this in a new tab. And if you come over here, you can see this is the official image, and there are versions over here of this image. You can see all these tags. So latest tag is one, Alpine is one. Okay, these are all tags basically that has been given. These are all different versions, and you can pull this images onto your system. Okay, you can see there are 1 billion plus pulls for this particular image over here, right? And you can run it this way. So this is the command to run the RabbitMQ instance onto your system. Okay, so everything is there over here. You can just take a look and explore this. So this is about Docker. I hope this is making sense. Okay, what I will do is I will take this over here. Okay, and this thing on this side. Okay, so that we have some room over here. Okay, now let us talk about the next concept, which is ECR. Now, what is ECR? So if I have to define ECR simply, you can think of ECR as Docker Container Registry on AWS. Okay, and it stands for, the full form of ECR is Elastic Container Registry. Okay, that is what it stands for. Okay, so it's basically a Docker Container Registry. It's a way to host your images on AWS. So like we saw Docker Hub, we have Docker Hub where you can come and host your images. So that like the same way you have ECR, which is an AWS service. It is by AWS, and you can come and host your images there as well. Okay, so that is what ECR is. Now, then you have something called as ECS. Now, what is ECS? So ECS over here is nothing but container orchestration service. Okay, and ECS over here. Okay, so it stands for Elastic Container Service. So I'll just write in over here, Elastic Container Service. That is what it stands for. So what is the meaning of container orchestration service? Okay, you know, if you have multiple images that exist, and if you want to run multiple containers, you can make use of this to run your containers in the cloud. Okay, so ECR lets you host your images. You can host and store your images on AWS using ECR, and you can run your images using ECS, Elastic Container Service. So this is a registry. This is the service that helps you run this. Now I hope this is pretty much clear. And then you have AWS Fargate. Now, what is Fargate in that case? So Fargate is nothing but, so AWS Fargate. Fargate is nothing but a launch type for ECS that runs containers serverlessly. So yep, I've added the definition here. Launch type for ECS. ECS meaning Elastic Container Service. So when you are trying to run, so see, understand the process over here. Okay, let's say you have in an application. It can be a Python application, it can be a Spring Boot application, any sort of application you want to containerize. You containerize that on your local machine. You have the image created. Okay, now that image runs successfully on your system. Now you want to take it to production. So what you're going to do is you're going to first store it on a Docker registry, right? And if you're going ahead with AWS for your infrastructure, it's best to make use of ECR over here, which is Elastic Container Registry. So what you would do is you would push the image. Okay, so let's say this is your app over here. Okay, what you would do is you would push your image to ECR. Okay, so your app is containerized and it has it is basically pushed to ECR, and your image is residing on ECR now. Now what you would do is you want to run this app, right? So the image that you've created contains your app and the environment, right? So you need to run it. So what you would do is you would take help of ECS over here. Okay, and ECS would come into picture and it would do the job of running the image that you have stored on in ECR. Okay, now when running your containers, there is a launch type. So how you want to run the container? So whether you want to run it with the help of virtual server, which is EC2 instances, or you want to go serverless, what do you want to do? Okay, so do you want to have server? Do you want your containers to run in an EC2 instance in the server? If you want to do that, then you can choose. So when you start running or when you create a ECS service, you will be asked for the launch type, like how you want to configure this and how you want to run this. Okay, when you define the task and service, when you actually are running your containers, you will be asked for the launch type. So you can select AWS Fargate, or you can select EC2. If you select EC2, it means you manage these servers. Okay, but if you don't select EC2, you can select Fargate. It means that your containers will run serverlessly. So AWS Fargate is nothing but a launch type for ECS that runs containers serverlessly. And serverlessly meaning there's no server. Okay, there's no server to manage, I should say. I'm sorry, there's no server for you to manage. Okay, server will be there in the hindsight, but you are not managing it. Okay, AWS is taking care of it. That is what AWS Fargate is. Okay, I hope all these terms are clear, because these terms are important. Okay, whenever you are learning something, you would hear these terms very often when you're working with containerization and AWS. So Docker, AWS ECS, AWS ECR, AWS Fargate. So Docker, what is Docker? Docker is a tool or a platform that lets you package your app and everything it needs into a portable container. Okay, you package your app into an image, and then when you run the image, it runs as a container. And what you can do is, if you can store the image on a registry. There are multiple kinds of registry that exist today. One is Docker Hub. Okay, and the other one, like there are different vendors or different companies have their own registry. For example, Microsoft might have its own on Azure. Okay, AWS has their own on Amazon, and Google will have their own on GCP. Okay, so ECR basically is the Elastic Container Registry, which is a Docker registry for AWS, on AWS for Docker images. Okay, so you can have your Docker images over here, and then you can when running your Docker images, you can make use of ECS, which is Elastic Container Service. And when running your containers, you will have an option to choose if you wish to run them serverlessly. If you choose that, okay, AWS Fargate, so you will be making use of AWS Fargate in that case if you choose to run it serverlessly. So I hope all of this is making sense now to you all. Now here I am in the AWS console, and let us explore ECR registry. So here you can search for ECR, and it should show you over here. So you can see over here, it is showing me ECR, Elastic Container Registry, fully managed Docker container registry, right? Now if you search for Elastic Container, you will see Elastic Container Registry and Elastic Container Service, right? So this is for Docker, like storing Docker images, and this is for running those images. They both are separate. Let's talk about registry first. So I'll go to registry, and you can see over here, share and deploy containers software publicly or privately. Okay, so it shows you over here, you write code, you package it, okay, into Docker image and send it to ECR. And from here, you can run the containers on ECS, EKS, or ECS and EKS both reside on Amazon Cloud. Okay, EKS is nothing but Kubernetes service, Elastic Kubernetes service, but we are talking about ECS. So ECR and ECS is what we are talking about. So now over here, you will see the benefits. You can explore this over here. Okay, there is a pricing as well, so you can click on this and know the pricing if you wish to. Okay, and it's a part of free tier as well, wherein you get 500 MB per month of storage for your private registry for 1 year. Okay, so this is something that you can leverage if you're learning. So come over here, what we will do is we will create a registry. Now over here in this registry, we need to store an image, right? So if you have a local image or a local application that you're working on, then so let's say I'm a Python developer, I'm working on Python application, so I can convert it into a Docker image. I can make a Docker image out of that application, and I can push it to ECR. So for that, I need a repository. Now repository is like a place that you're creating in the cloud within ECR, wherein your wherein your images will be stored. Okay, so that is something you can do. So this is a private repository that I'm creating. Okay, and which image should we store over here? So if you're a Spring Boot developer, you can containerize your Spring Boot applications and push it over here. But what I'm going to do is I am going to take some public image that is already existing. So here I'll come in, and here on Docker Hub, you have this image of Nginx. Okay, this is the official image of Nginx. So what I will do is I'll make use of this image over here. So what I will do is I'll come over here, ECR here, and I'll call this nginx, sorry, not m, this is nginx, and I'll call this as sample. Okay, something like this. Okay, so nginx sample is what I have called my repository. Image tag is mutable, and here this is the encryption setting. I won't alter any of them. Okay, I'll leave everything else to default, and I'll just say create. Now this repository is created. This is the URI over here. Okay, now before now one thing I forgot to mention is you should make sure you are in the right region over here from here. Right, so you need to make sure you are in the right region. Okay, and remember the region in which this is being created. Okay, because if once you're done learning, you should know where your registry is being created so that you can go and delete it later on. Otherwise, you will be charged for that. Right, if you're not in the free tier, you will be charged for that, and if you finish your free tier, you will be charged for that. Right, beyond free tier. So it's important whatever you're creating, you delete it. Right, so this is something that I've created. Now go inside over here. You will see there are no images over here, of course, because we've just created this. What you can do is you can click on this view push command and you will get all the commands basically for Mac as well as Windows over here. Okay. So what we will do is we are not pushing an actual app over here, but we will get the Nginx official image on our local machine and we will push it to ECR using the set of these commands. Okay, that's what we are going to do. So what I'm going to do for this is we are going to need Docker on our system. So if you don't have Docker, quickly come to docker.com and download Docker depending on your operating system and install it like any other software. It's just a normal software that you install on your system and you will see this kind of an interface. So open Docker desktop and you will see this kind of an interface. I already have a couple of containers created, a few images. Okay, so I play around with Docker a lot. I use this software a lot and that is why I have it already onto my system. Open PowerShell or any terminal on your operating system. So just open it like this. And what we will do is we will get the image first of all. Okay, so just see over here, it is trying to retrieve the authentication token. It is trying to build the image using this particular command over here. And then once it completes, so basically it is tagging my image to that of repository. So what I'm going to do is I'm going to come to PowerShell. Okay, and since I have Docker desktop installed, I can run Docker commands over here. You can see Docker commands. I did not get any sort of errors. So first of all, I'm going to say Docker pull, and I'm going to pull the image onto my local machine. Right, so you can see over here, this is the image over here, and what is the name of this image? So this image name is Nginx, and I need latest over here, the latest version of Nginx. Right, so what I'm going to do is I'm going to say Docker pull Nginx latest, something like this. Okay, I'll say enter. And now what this will do is this will pull the latest image of Nginx, and it will take some time depending on your internet connection speed. So it is pulling this entire image onto your system. And as soon as the image pull is complete, you will see the image over here in the images tab. So you can see this Nginx being created over here. Okay, this has been pulled locally. Now what I will do is here, if you see all the commands that we are getting, okay, here first of all it is retrieving the authentication token and authenticating our Docker client to the registry. Okay, so that is something we can do. So I'll just get this, I'll just copy this and let us do this. Okay, so I get this error. So when I executed this command, it did not work. Okay, and after doing a little bit of research, I found that this command is outdated in the latest version of CLI. I don't know why it's coming over here in that case. Okay, but it's there on the dashboard, and if you get any sort of error, do a little bit of research and you might be able to solve it. Okay, so how I solved it is I ran this command, the latest one over here. You can see this. So here I ran this, but I got an error because the region name was incorrect over here. And then I ran it with the right region name. So you can see this over here, AWS ECR get login password -2 times AP South 1. This is the region. Okay, -2 times region. You mention the region and then you log in using username AWS and password STIN. Okay, and you mention this. Okay, this is your ECR. So login has been succeeded. Now we don't want to build a Docker image. So if you have an application, you can build the Docker image like this, but I don't want to build a Docker image, right? I want to tag it instead. Okay, so I'll copy this one. Okay, this next command, and I'll come over here and I'll paste it. and instead of calling it nginx sample colon latest, I'll say nginx latest. Okay, because so you know what you're doing is you are tagging your Docker image with this name. So this name basically, which is the name of the ECR repository, is being added as a tag to your image. Okay, so you need to mention the current image name and the tag you want to add. Okay, so what is the current image name? Current image name is nginx latest, because that is what we have pulled over here, right? So nginx latest is the latest image, is the image that we have. So I'll just mention enter and you will see it being tagged. And now what we will do is I'll just say docker push and I'll get it pushed. Now before pushing you will see that there are 0 images. Okay, but let me push this. Oops. So I'll just say push and we'll wait for a while. So now what happened is we got the image onto a local machine. We added the right tag over here and then we pushed it to the ECR. So we have not modified the image or we have not done anything. We just got the image, a public image from the Docker registry, which is of nginx, and we are pushing it to our own created ECR repository. And you can see it's pushed over here. Okay. And here it's pushed, it's giving the confirmation. Now if you come over here, let me refresh, you can see one image has been added over here and this is the image URI, so you can copy it. Okay, I hope this is making sense as to how you can start pushing the images to the ECR repository in AWS. Okay, now I'll just reiterate over the steps. Okay, first step is after you create the image basically. So whichever application you are running, whether it's Python, whether it's Node.js, whether it's Spring Boot, whichever application you are running, first containerize that application locally. You will have the application containerized. Okay, you will have an image and that image will have a name, right? Then what you do is you need to log in. You authenticate yourself over here with ECR. So here, that is what I've done. Authenticated myself. You'll get this command from the dashboard itself. That is what I did. And then come over here and say docker tag and mention the image name. So here the image name in my case was nginx latest. This was the image name, right? So I've made that image name. I'm making use of nginx docker tag nginx latest, and I'm mentioning the image name over here. Sorry, not the image name, the name of the ECR basically that is being created. Okay, this is something that I got from the dashboard over here. Okay, this is what I'm doing. Okay, so I've tagged the image with this ECR and then I just did docker push and I mentioned the repository URL and the image name over here. You can see this. And the image got pushed over here and you can see this is what the command was. The image got pushed and you can see the image over here. So I hope this is making sense and I hope you have now a good understanding of ECR. Now after you have an image on ECR, the next step is to run it, right? So what you can do is, let me duplicate this tab a bit, okay, and I will come over here and I'll search for ECS over here, which is Elastic Container Service. Okay, so let us go over here. Now this is what Elastic Container Service is. Here you can run fully managed containers. You can see it's highly scalable and everything. It's easy to run, stop, manage containers in a cluster. So you will see this term quite often, cluster. What is cluster? So cluster is nothing but a logical group or an environment where your containers can run. Okay, you can think of it as a place where your containers are running. Okay, and inside a cluster you can run many tasks and services. Okay, so there are a few terminologies when it comes to talking about ECS, and we'll talk about those terminologies as well. But for now, you can take a look at ECS over here, and you can see over here serverless option. So ECS provides a serverless option with AWS Fargate. Okay, and using AWS Fargate, you can run your containers in a serverless mode. But if you want to also have servers in place, you can make use of Amazon EC2 instances as well. And when you're creating and provisioning clusters and when you're creating task services, you will have an option to choose which way you want to or which approach you wish to run with. Okay, whether it's serverless with Fargate or with EC2 instances. So all of that we'll be taking a look at. Okay, you can see all of the other features as well. Okay, so here what I'm going to do is I'm going to say get started here, and there are no clusters, right? So what is the first thing we would do? We would create a cluster. So I would say create a cluster. Okay, and here it is giving a default name. Okay, so you can I'll just stick to this name. If you want to edit it, you can edit it if you wish to. Okay, now you can see over here for service connects, I'll just stick to default over here. Infrastructure. Okay, now this is where you will configure your cluster as to how your containers are supposed to run. Okay, so you can see over here, you can choose AWS Fargate for going ahead with serverless mode, or you can add Amazon EC2 instances. So you choose either of the two. So for AWS Fargate, you pay as you go. Okay, and for EC2 instances, there will be some manual configuration. So I'll just choose AWS Fargate. Okay, so what is AWS Fargate? AWS Fargate is a launch type for your containers, basically over here, wherein you run your containers in a serverless mode by checking this option. Okay, you can read more by clicking on this info button, and you'll see some documentation over here, right? So this is fine over here. Now, if you scroll down, I don't think we need to select anything else. Okay, I'll just say create over here, right? So the moment we do create, okay, this creation is in process, and this will take a bit of time. Okay, so we'll wait for a while until this process finishes. So when creating the cluster, I got this error. Okay, and this error says resource handler returned a message, invalid request provided, create cluster in unable to assume service linked role. So this is very important, unable to assume service linked role. Now understand this, ECS over here, this is Elastic Container Service. It's a managed AWS service, right? So ECS, to run the containers on your behalf, it also needs to talk to other AWS services, right? It might need to create a load balancer, or it might need to do anything to run all of this, right? So it needs certain roles and permissions, and that is what it is telling. It is not able to assume this service linked role. So please verify that the ECS service linked role exists. Okay, so what we need to do is we need to head over to IAM, and in IAM we need to check if this role exists. So I'm going to come over here, IAM. Okay, let me open this IAM in a new tab, and here I will head over to the user admin courses. So this is my user. Okay, and here, sorry, not user. So I'll have to come to roles over here. Okay, so basically we'll need a role. So if you come here, you need to see this, or you need to search for this name over here, AWS service role for ECS. And this should exist because this is defaultly created. It is created by default by AWS, and under trust relationship, you should see that this role exists. Okay. Now the problem is we are still getting this error over here that we saw, right? Ideally, it should not have happened. But let me try this again. Let me try creating the cluster again. It could be possible that there might be some sort of cache. Okay, and it did not allow me to create. So I'll again try creating this. I'll make sure AWS Fargate is selected. I'll say create, and let us wait for a while. Okay, so my guess was right. Okay, probably there was some temporary issue. And right now you can see this cluster is created. Okay, so sometimes this might happen wherein you're trying to create a cluster and you get this error. Okay, just wait for a while after you access Amazon ECS. Okay, there might be some backend tasks running or something like that, and there might be some sort of cache that might make that error happen, which we just saw. Okay, so yes, this is created. Now this is a cluster, which is like an environment where our container is going to run, and it is Fargate based over here, right? So now if you go over here, okay, inside, you're going to see some things over here like services and tasks. Okay, of course there are tons of things like infrastructure, metrics. You can see a lot of things, schedule tasks, configuration, tags, and all of this. But under services, let us talk what services are, because we are going to create a service. We are also going to create a task. So what is a task first of all? So here you need to create a task, and that task is basically defining a running container or a group of containers. So you basically are defining the blueprint of what all containers you wish to have running in this particular cluster. So that is what you create a task for. And then you have services over here, which is like a manager at the top, and it ensures that a certain number of tasks are always running, and features like auto scaling, load balancing, restart on failure, all of this are taken care of. Okay, so service is basically making sure that everything is running fine, and task defines as to how and what things run. Okay, so what we will do is we will start creating these. So first I'll create a task. Okay, so I'll say run a or there should be a task definition over here. Okay, task definition. So on the left hand side you can see task definitions, right? So go over here because you need to add a task definition to create a task. So I'll say create a new task definition. I'll just get rid of this. I'll say create a new task definition, and you will see a page like this. So here I'm going to say Nginx task over here. Okay, and here we are specifying the infrastructure requirements again. So I want to have the launch type as serverless, okay, which is making use of AWS Fargate. I'm not making use of Amazon instances, EC2 instances, right? So I'm not making use of AWS EC2 instances. I'll just select Fargate, and I'll just scroll down task roles. I'll just leave everything as is. Okay. Now here you have container details. Okay, so you need to mention. Or 1 second. So there is a role requirement as well. Task role. Create a new role. Okay. So there is no task execution role. So I'll just skip this. Okay. Now coming to container over here, we need to mention the container name over here. Okay. So container name basically is the name with which your image runs in the cluster. So I'll mention Nginx. Okay. Nginx over here. You can mention any name. That's completely fine. And then over here, you will mention the repository URI, or this is the format in which it comes. And if your image is hosted on AWS ECR, so you can click on this. Okay. And here you can choose the repository. So Nginx sample is the repository that we had created. And then you can select the image over here. So one repository can have multiple images. So you can select which image you wish to add over here. Okay. And you can say use image tag latest. Okay, so the image will come over here, and then you scroll down. Okay, I don't think there is anything else needed over here. Just make sure like the container port is mapped to 80, because within the container our application will run on port 8080. Okay, and this might be different for your application. So if you are running a Spring Boot application and if you are running it on a certain port, so you have to make sure you do the port mapping over here. Okay. Scroll down, scroll down, scroll down. Nothing else over here. Okay, nothing else. So nothing else is needed over here. We'll leave everything else to default. Okay, and I'll say create over here. So this task definition will be created. Okay, and it's basically a blueprint for running containers. Okay, so this is created, task definition. Now what we need to do is, once task definition is done, I'll go to clusters. Okay, within my cluster, I will come over here and I'll say create a service. Okay, so I'll say create a service, and we'll see this this page over here. Now here we need to select the task definition family first of all. Okay, so I'll select the task that I've created, which is Nginx task. Okay, and here this is the service name that it has auto created. And if you scroll down, it is basically asking me to choose the compute options. So I'll leave all of this to basically default. Okay, you can modify this if there are any specific deployment requirements for you all. But if you come over here under networking, since we want to make sure that we are able to access the Nginx page from the browser after deployment, if you come over here, you have to make sure that public IP is turned on. Okay, should be turned on. Now scroll down over here. Okay, from here you can choose the right VPC and all, but I'll just leave this to the default ones. Okay, if you have any specific VPC created, you can add that. Then you scroll down and say create over here. Now once you create this, okay, you will see the service creation will start and deployment is in progress. Okay, so we'll wait for a while until this completes. Now after waiting for some time, you can see it is still showing me in progress. Deployment is in progress. But I can see service is active over here and task is also running over here. This is a task that is running. Okay, using the task definition. So service is now making sure that our deployment is up and running. So I've still not got a confirmation. So probably there are some background tasks that are still going on. So I'll wait for a while again. So now is when I see a confirmation. This actually took few minutes, okay, to complete. So everything is done, and now you can see over here that it has been deployed successfully. Now what I can do over here is you can go to tasks. You can see task running. That's fine. You can go inside a service over here, And inside the service, you will see different tabs. So you can check like everything around your application. So you can see the health over here. You can set alarm over here. All of this you can do. Okay. And you can see what all tasks are running. Like we could see outside. You can see the logs as well. Okay. So if you want to see any sort of logs, you can see that over here. You can take a look at the deployments over here. Okay. And then you have events. So what all happened over here? Okay, the list of events that happened. So when it wasn't ready, when a task was started, all of this. If you go to configuration and networking here, you should see something called as public IP. Okay, I don't see a public IP over here. Okay, public IP assigned. I don't see a public IP here, but it should be in this tab. Not over here. Okay, I'm in the wrong place probably. So I'll go to services. I'll go to tasks. Here within the task, I should see this public IP. Okay, so public IP comes within the task. Okay, so come over here. I'll just get rid of these messages. So public IP, you can say open address. And if you click on open address, it should open in a new tab. Okay, or you can just copy the IP address and paste it in the browser. So now we should see a welcome page for Nginx. And if we don't see the welcome page, there is probably an issue that the page is not accessible. So the service is definitely running in the cloud on Fargate. Using ECS, but okay, it's not able to reach this. So there is probably a security sort of restriction that has been added. So what I will do is I will come over here. I'll go back. I'll go to service. Within service, I will check this. I'll go to configuration and networking, and I'll go to the security groups over here. So let us check the security groups. Okay, so there might be, okay, so we'll have to add an inbound rule over here. Okay, so I'll say edit. I'll say add a rule over here, and I'll say all TCP requests from anywhere should be allowed, and I'll save the rule over here for this particular security group. Okay, all traffic should be allowed from anywhere, and that is what I've done. And now if you try to access, let us see. Okay, you can see now it's working fine. You can see welcome to Nginx. This is working absolutely okay, right? So yes, this was good, and I would highly recommend that the changes that you did over here for all the traffic, okay, all the traffic, the thing that you created, please delete that. So this is the one that I had created, like from anywhere is what I had mentioned over here. Okay, so this was the one. So I'll just get rid of this and I'll say save rules. Okay. So I've updated the security groups now, and again now this page should not be accessible. Okay. So I'll tell you the reason why I reverted this change over here, because this VPC might be used for any other service, and this inbound rule basically is opening up all the traffic to via this particular service group. Okay, it's opening up all the traffic. So I don't want that to happen, because if I use this VPC somewhere else, sorry, not this VPC, but this security group somewhere else, then it will create a problem. So I just reverted to the old change. The goal was just to see that this is deployed and it is working absolutely okay. You can see it was accessible through the browser. And if you have the application, anything that you have deployed over here, okay, you should also see that running with this. Okay, so I hope you have been able to follow along and you could understand as to how you can run your containers using Fargate. Now, once you're done understanding this, it's important that you clean up like all the clusters, services, tasks that you have created. Okay, so what I would recommend is you come over here to services, you get rid of this service, you delete this service. Okay, because AWS is going to bill you for the usage. Okay, it cannot be stopped while it's scaled above 0. So if you see this issue, what you do is you go to services. Okay, so inside services, so one second. So here, if you come, you go inside services. If you see this sort of error log, click on update service, and here instead of where you have desired count. Okay, so desired count is desired tasks. So here I'll update this desired task to that of 0, and I'll say update over here. So the moment you update, the service is updated. Okay, now come over here to services. If you see tasks, okay, you will see this is stopped now. Okay, you can see last status was running, so this will be stopped now. But if you come over here, this needs to be deleted. So I'll say delete the service. I'll say delete, like so. Okay, and I'll say delete, and the service is gone. So service is gone. This task will also be deleted. So I'll say stop all. Okay, so stop all tasks over here. This is done. Okay, so no task to stop. So this is already stopped. That is absolutely fine. I'll also get rid of this task definition. I don't. Okay, is there a way to delete this? Okay, I don't see an option to delete this, but that is fine. So you go to cluster and get rid of the cluster. So over here, I'll just delete this cluster. Okay, so you need to type this over here, the delete and cluster name to confirm. So the cluster will also be deleted. Now, if there is any sort of load balancer or anything that is created, that also needs to be deleted. So meanwhile, the cluster is being deleted. I'll also come to ECR over here. So Elastic Container Registry. Okay, search for ECR and come over here. And you have the image hosted over here. So get rid of this as well. Okay, because you will be charged for host or storing images on AWS. Okay, so just do this and come over here, and then you should see there are no images over here. Okay, and if you come over here, was this deleted? This, okay, this cluster was deleted. So if you come over here now, there are 0 clusters, 0 namespaces, no task. Okay, task definition is there. Okay, this I don't see an option to delete this, but that is absolutely okay. Over and above, what I would recommend is you should head over to EC2 console and also check for, here if you come, you should check for elastic IPs. If there were any elastic IPs that were created during the creation of, clusters. And if they have not been deleted, you should delete it from here. You can check for load balancers over here. If there are any load balancers, if there are any, please delete it. They would cost you money. And yeah, this is it. I think there should be target groups over here as well. I don't see the target groups option. Okay, that's fine. So target groups, there is no target groups. Okay, so elastic IPs are not there, target groups are not there, nothing is there, only task definition is remaining. So come over here and here just go inside task definition, inside task, and here you will see action and deregister. So just deregister this one. And the moment you deregister this one, you will have an option to delete. So you can delete it. So task definitions don't cost money. You can have task definitions there. Okay. But I'll just delete it so that there is a bit of cleanliness over here. So task definitions are gone. Okay. So we have cleaned everything and now we won't be billed for anything. I hope you have been able to follow along and I hope this was useful.